Okay, we should all be on this page, and just make sure you're on the right page. So like this shape down here should be at the bottom of your page on your notes. So make sure you're on the right one. But we're going to start out today exactly like what we did yesterday. So you might still want your patty paper. You don't have to use your patty paper to do your rotations. Okay, some of you might actually start to just feel comfortable with just doing it by yourself. But if you're not there yet, that's fine. I gave you guys patty paper yesterday, so you should be able to use that and do those rotations. So just like what we did yesterday, trace your two triangles there and trace all the markings, all the side markings, all the angle markings, and then you're still doing a 180-degree rotation around that point M. So I want you guys to do that. I'm going to give you like 1 to 2 minutes here to do those two rotations. Make sure you mark everything up, because then we're going to start talking about the shape and what properties it has. Okay, as you're finishing up yours, double check, make sure that they match. And again, make sure you have all the things marked. What shape did you guys just create there? Good, a rectangle. All right, so yesterday we spent some time talking about a parallelogram, and I had said yesterday that parallelograms are kind of like a rectangle, except they're slanted, all right? So now we're talking about this new case of if it's no longer slanted, it is standing straight up and down, it's a rectangle. We're going to answer the same questions that we did yesterday about its sides and its angles and its diagonals. Now, you guys probably already know most of the stuff about rectangles, so I'm not trying to trick you today. I'm not trying to like throw in any random new information that you're like, I've never heard that before about a rectangle. Now, we might discover some things that yesterday we said no to for a parallelogram that we're going to be able to say yes to now, because we are dealing with the rectangle. So it is a slightly different shape, so it might have more of those properties that a parallelogram didn't have yesterday. Okay? But don't overthink this. This is not supposed to be super hard when we're answering these kind of questions. So down below, in our first chart where we're talking about the sides, first one says opposite sides are parallel. Do you guys think that's still true for a rectangle? Yes. We talked yesterday about like slope of lines on parallelograms. If I'm looking at this one on the right-hand side, the top and the bottom would both still have zero slope because they're flat lines. the left and the right side would actually have what we call undefined slope because they're vertical lines, but they would still be parallel to each other. Okay, we also said yes to that yesterday as well. The second one we said yes to yesterday. Do you think it's still true that on a rectangle opposite sides are congruent? Yeah, how do we know that?
Because the two short lines are together.
Yeah, those markings help us out again, right? Plus, you probably have known that since you were maybe in preschool. Like when you learned about a rectangle for the first time, you were probably told, two are longer, two are shorter. You got them matching because they're opposite from each other. All right, the third one on the sides is asking, do we have 4 congruent sides?
No.
No, not necessarily. Now, if we did have 4 congruent sides, then we're probably not dealing with a rectangle anymore. Probably dealing with a square, maybe even the rhombus. We haven't talked about that yet. Okay, but those side properties, those were the same as parallelograms. We didn't really change anything with that. Now let's go into the angle properties. Opposite angles are congruent. Yes or no?
Yes.
Yeah? How do we know that they're congruent?
Because one has a right angle.
Well, we've got right angles on a couple of the corners. What about like this corner here? It's got like a closed circle and an X. Does the opposite angle have the same markings?
Yes.
Yeah. So again, using those markings help us understand if they're equal to each other or not. So we're safe to say yes again. What about same side angles? Do we still think they would add up to 180 on a rectangle? Remember, same side angles would be like these ones here, or like these ones on the bottom.
Yeah, they would add up.
Would they add up to 180?
Yeah.
Why do we know that?
Because there's right angle, and the other one, there'd be 45-degree angles.
Okay.
Because there's 3 angles, like 3 angles in a triangle.
There are 3 angles in the triangle.
Yeah, but like there's like 3 in the bottom too, which match the ones in each individual triangle.
Yeah, exactly. Like she's taking that idea, we rotated this triangle up here. So if we know that this is 90, you know that the X and the closed circle also have to add up to 90. And we rotated that around. So we're combining the same 2 pieces from that triangle that we started with that we said had to equal 90. So we know this has to equal 90 as well. That's great reasoning. So yes, you should be able to say those same side angles are going to add up to 180. Can we say on a rectangle that all 4 angles are 90 degrees? Yeah. I'm not trying to trick you. You guys probably know that already about a rectangle. Hopefully. That all 4 angles are going to be 90. And that kind of just goes right off of what we just talked about on the last problem. If the same side angles have to add up to 180, and if this one is 90, then this angle over here also has to be 90 to get to your 180. So, yes, all 4 corners are going to be 90 degrees on a rectangle. Okay, so for that one, we switched the last one from a no to a yes. Like yesterday we had to say no to that last one for parallelograms. Now we're saying yes for our rectangle. All right, now let's talk about the diagonals. We went over what diagonals were yesterday, and you already have one of the diagonals drawn in on both of your shapes, but remember there would be a second one. So I'm going to go ahead and draw that in. Okay, now talking about the diagonals. The first one, it's asking, do they bisect each other?
Yes.
Remember, we said bisect means cut in half. You guys are saying yes over here? Do you guys agree with them? Do the diagonals look like they get cut in half? Yeah. How could we test it, like if we were maybe a little unsure? Could you do something with your patty paper? You could fold the diagonal in half and see if the 2 lines line up. You could even just put your patty paper like on top of half the diagonal. So like I would just put this on here and I would trace like from this corner to that center point M and then just slide it up and see if it matches. That'd be a really easy way to double check and make sure that they are truly equal to each other. Okay. So if I did that, they should bisect, which means that we should be able to say yes here. Don't be afraid to use your patty paper. Even though we're done with the rotation, you already have that shape traced. You can still use those sides to help you kind of solidify your thinking on some of these questions. Do we think the diagonals are congruent to each other?
Yes.
Yes? Again, if we were unsure, we could use pad paper to check it out. Like you guys could do this actually right now. So if you have your pad paper in front of you, when you trace your triangles, like this one, you should already have that diagonal on your paper because that was from the triangle that you traced. Just take this side here, guys, and rotate it so that it connects from the other point to point and see if it lines up perfectly. So if you have your pad paper, you could just do that really quick. You could just take that triangle that you traced, just rotate it a little bit and see if those corners match. They should. So you should be able to say yes here. Okay, that was the first one we said yes to in this column that we had to say no to yesterday. We were not able to say that for parallelograms yesterday. Okay, the next one. Are the diagonals, what's that upside down T mean again?
Perpendicular.
Perpendicular. What's happening when things are perpendicular?
And create a right angle.
Right angle. So right at that point M, does it look like 90-degree angles are being formed? I heard yes and no.
No.
No? How do you know?
No, yeah.
Well, especially like this one maybe. The first one I think is pretty obvious to see. Like this is an obtuse angle. This is way over 90. Because like 90 would come up here. And that goes off that way. And this would be acute. It looks like it's less than 90. Now these ones are maybe a little bit closer to 90. But I still think you have a 90-degree box right down here. You could trace that on your pad paper and move that up to that corner. It's probably not going to be a true 90 degrees. So I think we're going to have to say no. Diagonals are angle bisectors. So those corner angles on our shape, when those diagonals were drawn in, do we know if they got cut in half perfectly? No, why not?
Because one side is longer than the other, so the diagonal is going to get more stretched in a certain direction.
Okay. It does make sense to me, yeah.
Smaller.
Mm-hmm. Okay. Are there markings on the picture that I could use to show why those two halves of the angles aren't the same? What's happening in this corner here?
One's an X and one's a
One's a dot, one's an X. So what is that telling you about those two corners?
They're different.
They're different. They would still add to 90. So like maybe the X is 60 degrees and maybe the dot is 30 degrees. Or 50 and 40 or something other than that. It doesn't have to be those numbers. But because they're not the same, they can't be 45, 45. Because if they were both 45, they would probably be using the same symbol for all of those angles. So I don't think these angles are going to be cut in half necessarily, so we have to say no to that one. So if you look at this chart, and even if you just were to do like a really quick comparison to the chart that we did yesterday, some have switched to yes. Not many, but a few have. As we keep going throughout the next couple of days and we get into the like other shapes, we're going to start to see more of those no's becoming yeses because we're getting more specific about a shape that we're working with here. Okay, so you'll start to see that a lot of these shapes like parallelograms and rectangles have some similar properties. And they're going to share those as we get into the rhombus and the square. But then more of them are going to also start saying yes, because as we add like more specifications to our shape, it's going to really limit what it can look like. Now down below, we have the picture of this rectangle. We're going to summarize everything that we just talked about. So the first thing is that, my opposite sides would be congruent to each other and they would be parallel to each other. So yesterday I used dashes to show that opposite sides would be congruent. And then we talked about how parallel would mean there'd be those arrows on your lines as well. But if you remember, I drew them above just to have less clutter on our side lines because it gets kind of jumbled fast. But those arrows are just reminding you opposite sides would also be parallel to each other. Then we talked about that all four angles are truly 90 degrees. So I'm going to go ahead and just put little 90-degree angle boxes in all my corners. But then that also guarantees opposite angles would be congruent because opposite of each other would always be a 90-degree angle. And same side angles would have to add up to 180, because if you use the 2 on the left-hand side or the 2 angles on the bottom or the 2 on the top, they're going to add up to 180 because it's 90 plus 90 every single time. And then the last thing we need to add here is the diagonals. Now, if you remember yesterday on the parallelogram, I'm just going to scroll back up to that for a second. The diagonals up here bisected each other on a parallelogram. That same thing is happening on a rectangle. However, the rectangles' full diagonals are also congruent. That wasn't true for a parallelogram. That's why I use like 2s and 4s to kind of illustrate that point. Down here on a rectangle, though, if the diagonals themselves are congruent, then all 4 of those small little pieces of the diagonal should be congruent as well. So I'm just going to say if this is 5, then this has to be 5, this has to be 5, and this has to be 5. But it doesn't have to be the number 5. They could all be 6s, they could all be 10s, they could all be 20s, they could all be 17.3. It doesn't really matter what the number is. I'm just trying to show you that those pieces of the diagonals would be congruent. Now I want to take this just one step further, guys, because this will come in handy when you do your homework today. What's true? I'm going to highlight some stuff. What do you guys think is true about this triangle and this triangle that I'm highlighting in yellow? They're the same. Okay. What about then, let me do like orange, this color. So over this triangle and this one, what do you think is true about these? They're also the same. Okay. Here's another question I have for you. If these diagonals are both 5, so like this side would be equal to this side, what kind of triangles do I have in there? Isosceles triangles. So what's true about like this angle and this angle? They would have to be the same. So when you guys do your worksheet today, you'll see some problems where it might seem like that angle that you're trying to find is impossible to do with the information that they give you. Start thinking about what we just went over there. I highlighted some of those triangles for you to show you that this rectangle is made up of these smaller triangles, and there's going to be some congruent triangles in there, and there's isosceles triangles. There's actually multiple isosceles triangles because the top and the bottom triangles would do the exact same thing too. It doesn't mean that all those corner angles would be the same, because the top, like the orange triangles, those, like the bottom side is longer than the yellows. So those angles are going to differ a little bit in those corners, but you should start to see those relationships, and that might help you solve for things on your homework. Okay, do we have any questions on that? We feeling okay about a rectangle?